Hi, I'm Bob. Let's review the first quiz. Part 1 is about the revenue function and profit function of a monopolist. The revenue function of the monopolist is P times Q, where P is a function of Q. The marginal revenue function is the first derivative of the revenue function with respect to Q. Using the product rule and rearranging the terms, we can attain a function of price and price elasticity of demand. On the other hand, marginal cost is the first derivative of the cost function with respect to quantity. The profit function is equal to the revenue function minus the cost function. The first order condition for maximum profit is that the first derivative of the profit function with respect to quantity is equal to 0, which implies the marginal revenue is equal to marginal cost at the optimal point. Using the expression for marginal revenue and marginal cost, we can write the price as a function of A and epsilon. When the price elasticity of demand approaches negative infinity, which means when the demand is completely elastic, then the price approaches marginal cost. For question 5, we use the chain rule. Price is a function of epsilon and A, and epsilon is a function of time. Notice that A does not change with time, so the second term is 0. The partial derivative of price with respect to epsilon is positive. If demand becomes increasingly elastic over time, that is to say, if d epsilon dt is negative, then the whole thing, d price dt, is negative. A negative dp over dt means price decreases over time. For question 6, A is also a function of time. By chain rule, dp over dt has two terms. The first term is the same as part 5. Let's look at the second term. dA over dt is negative. Partial p over partial a is positive because epsilon is less than minus 1. We know that a monopolist only operates in the elastic portion of its demand curve, where epsilon is less than minus 1 to ensure positive marginal revenue. So the second term of dp over dt is negative. Since it has one more negative term when it's compared to part 5, the price decreases over time faster than that in part 5. Part 2 is about a utility function and a constraint maximization problem. The marginal utility of good X is the partial derivative of utility with respect to the quantity of good X, holding good Y constant. The marginal utility of good Y is the partial derivative of the utility with respect to good Y, holding X constant. The slope of the difference curve can be obtained by using the total differential of the utility. The change of utility, delta U, is equal to 0 along the indifference curve. The second derivative tells us whether the indifference curve is convex or concave to origin. For question 4, we first write y as a function of x and replace it into the utility function. Now the utility function only contains one variable x. The first order condition for utility maximum is that partial u partial x is equal to 0. We can verify that the sufficient second order condition for a utility maximum holds because the second derivative is negative. For question 6, from the first order condition, we can solve for the optimal quantity x. Using the budget constraint, we can get the optimal quantity of y. The utility function is simple in this question, so we can get a closed form solution of x and y. We use the solution of x and y in the last 3 questions. We take the partial derivative of x and y with respect to monthly income to see whether they are normal goods or inferior goods. We take the partial derivative of x and y with respect to their own prices to see whether the demand curves are downward sloping or not. We take the partial derivative of x and y with respect to the other goods price to get the cross price effect, which tells us whether they are substitutes or complements. Thank you for watching the video.